So, what can you expect from this presentation? First off, you will learn some details about service endpoints, what they are good for, as well as private endpoints, of course. We will compare both of them to each other, find where the subtle differences lie, and we will learn when to use one or the other. I assume some basic understanding of virtual networking and DNS and IPv4 routing and how this works in Azure. As everybody introduced themselves, now it's my turn. Yeah, as you have learned from the introduction, my name is Matthias. People usually call me Günni by my nickname. I'm a father of two little kids, and these little monkeys really keep me busy. I live in Switzerland and Canton Zurich, at a city close to Affoltern am Albis. And my spare time, I do some digital photography, but also enjoy some supermoto riding. And I'm a big fan of this brand Hasselberg that unfortunately vanished or got bought by Husqvarna. Professionally, I am working as an Azure Solution Architect. I am a tech enthusiast, and I have mainly a system engineering background. I have nearly 18 plus years of IT experience, but I have also been working as a .NET C# developer for a major bank in Switzerland, where I was developing applications for the trading floor. I also love to blog and write about stuff that keeps my mind busy. I would like to invite you, come and have a look at azureblue.io. Leave a feedback if you maybe you find something that's interesting. If something you dislike, just drop me a mail. I work for a consultancy company called Saviva, and we are focusing on software solutions in the insurance sector, and we support also their move to the public cloud. And okay. So without further ado, let's dive into service endpoints. I structured this part into a couple of sections. I will first give an overview, then so that we can better understand what service endpoints are. We need a more in-depth understanding of how routing works in general in Azure. Then we will go back to service endpoints and have a look at what service endpoint policies are. As I don't want to give too much theory, I would like to round or give a demo in addition, and finalize this with the key benefits and the limitations that apply to service endpoints. So as an overview, basically service endpoints is a feature of Azure Virtual Network. It is not a standalone resource like for example, a storage account is. It is part of Azure Virtual Network. And what it does, it allows you to eliminate the exposure to the internet and protects from data exfiltration. I think that's the main selling point of service endpoints. It allows to tightly lock down your Azure resources, and it mainly enables data traveling from a client, from a virtual machine towards a storage account, for example, to remain on the Azure backbone. So by using service endpoints, all your traffic will remain on the Azure backbone, which is a big benefit. So in the beginning, I forgot to mention that in case any questions should come up while I'm speaking, please raise your hand or just drop the question inside the chat, and I will try to answer it right away. Okay, let's now get to Azure Routing. Whenever you create a subnet inside an existing virtual network, Azure creates a system default routing table on the background for you and attaches this to the subnet. And this will ensure that every outbound traffic leaving the subnet will make a routing decision based on this default routing table. And the table here depicts the main entries that are part of the system default routing table. And there's one column that is important to note, which is the next hop type in the middle. So there are several next hop types that decide where a packet is getting routed to where it's gonna travel next. So this default routing table usually contains an address space that is unique to the VNet. In this case, for example, it's a 10.0/16. Then we have this catch-all final IP address, this 4x0/0 that has a next hop type of internet, which means that by default, if none of this address prefixes beforehand matches an outgoing IP address, it will hit this IP address and will be forwarded to the internet. Then we have list IP ranges that are, not all of them, but at least the first two of them are part of RFC 1918, which are private networks, and they have a next top type of none, which means traffic destined to these directions will be dropped. And yes, this is basically what this system default route looks like. One important thing to note here is that you can't remove or delete or add anything related to the system default route. However, you can override these routes by adding user-defined routes by creating a custom routing table, but this default route tables can't be modified. Another important aspect is how Azure selects the route for an outgoing IP packet, and it does so by applying an algorithm that is called the longest prefix matching algorithm. Which is quite simple. What it basically does is, for example, let's have a look at. Let me just enable my laser pointer here. For example, let's have a look at this routing table on the right side here. Let's assume that a packet leaves the subnet having a destination IP address of 10.0.0.5. Now, what will happen is both of them, I mean, this IP address lies in the address range of both of these routes, right? But as /24 is a longer matching prefix than /16, it is more precise, right? It will choose the next hop type B. Whereas, as an additional example, an IP address of 10.0.1.5 would go to the next hop type A, as it is not part of this 10.0/24 network. Okay, and there might be situations where different routes concur against each other, or that there are routes that have the same address prefix, and then a rule of priority applies. So there might be user-defined routes that I mentioned before that you can use to override existing system default routes, and there are BGP routes of system default routes. So usually the user-defined route has the highest priority, followed by BGP, and then comes the system default route. I try to depict this in this table here. That shows in case we got one route that comes from the default routing table here, depicted as source, has an address prefix for 0, where next hop type is internet, and one from the user-defined. If now a packet with a destination IP of 20.123 and so on will hit this routing table, it will select the user-defined route as its priority is higher. So this just as some background information. Okay, let's now have a more bird's eye view on how routing works. This diagram shows on the top view where we see the Azure data center. on the bottom we see the public internet. We have a virtual network here, 10.0/16, that contains a single subnet, 10.0.1/24. Inside we have two virtual machines, one having a public IP address and a private IP address. I call it jump host, and the virtual VM that only consists a private IP address. I also added this icon to show that the system default route table applies. And one thing that is important to note is this fully managed net icon here. Now, by adding this icon, I did not meant to refer to the NAT resource that you can manage inside Azure. This type of NAT here is fully managed by Azure and is and you won't find it anywhere in the configuration. I just added it to make clear that also a virtual machine that has no public IP address is able to communicate to the outside world. And it does so by leveraging this integrated NAT service. So looking at the example here, if this VM demo1 VM would like to talk to the storage account here that has a public IP address, this communication will leave the subnet, will travel through the internet and go back in to the storage account, to the Azure perimeter. Well, this is for obvious reasons not that optimal, because a third party might be able, even if it's unlikely, might be able to intercept the data. At the same time, it introduces latency and jitter that is negative for the performance. Why not go straight from this virtual machine to the storage account? By having added this little laptops here on the bottom and this green check mark, I wanted to depict that the storage account is still reachable from the internet, right? And also this jump host, of course, because it has a public IP address. This virtual machine doesn't, because it's kind of protected or hidden behind this fully managed NAT. So okay, this forms the basic of how routing works in Azure, just in a nutshell. Okay, now let's proceed and see how service endpoints work. Basically, service endpoints rely on routing, and they introduce a new next hop type called virtual network service endpoint. And this additional hop type acts as an ingress or an entry point to the Azure backbone. And now the sentence on the bottom is very important, because it says when you're enabling service endpoints, you always enable service endpoints on a subnet. By the way, I will show you later in the demo. It will, when you enable service endpoints for a specific resource type, the public IP addresses belonging to that service endpoints will be added to your routing table, and having a next hop type of virtual network service endpoint, which redirects all traffic towards this target resource to this ingress point into the Azure backbone. Okay. Now one more part we need to understand is how service endpoint policies work. They're not a big thing. I mean, what a service endpoint does is it allows you to filter egress traffic towards a storage account. So let's have a look at the picture here at the bottom, where we have a client that would like to communicate to a storage account via service endpoint. Now let's assume we have two storage accounts, but you would like to ensure that only one storage account is reachable via service endpoint from the subnet. Now this is where service endpoint policies comes into place, that lets you pinpoint or lock down the communication towards this the storage account. And it allows you to granularly filter based on several scopes. For example, you can say, okay, I would like to allow communication to all storage accounts being part of a specific subscription, or only storage accounts belonging to one special resource group, or only to a single account. But service endpoint policies are very limited in their use, because you can only use them with storage accounts. So there's no way to use them with SQL databases or anything else. It's despite the name, it's only usable for storage accounts, and I think it should be renamed to something else, like I don't know, maybe storage account service endpoint policy, whatever. Yeah, one additional note here at this point is that service endpoints are pretty old. I mean, compared to private endpoints can be considered the successor. So I guess Microsoft's intention here was to build this service endpoint policy approach out, or further introduce more filtering capabilities that kind of never happened. But it's just a wild guess from my side. Okay. Let's now see some practical stuff and leave the theory behind. In this small demo, I would like to show you how we can lock down a virtual machine and a storage account with service endpoints. Again, the image, this diagram, you've seen it before. What I would like to do is make this virtual machine communicate to the storage account via service endpoints, and at the same time locking down access to another storage account that is part of my subscription. I would like to deny outbound access so that we kind of revert this masquerading or this NAT gateway that applies implicitly, and deny inbound access at the same time. So, okay, let's see. First of all, we're gonna create a service endpoint policy, as this is a prerequisite that we later can enable the service endpoints. Oh my gosh, it's already there. That's just another one. So basically, if you don't have a link like I have here, you just go here and search for service endpoint policy, and you will end up at this dialog. So no big deal here. You click on add, make a selection on your subscription. I'll put it in my demo resource group here. Let's call it service endpoint policy Azure Blue demo 1, whatever. Location with Europe is fine. And now the policy definition, that's a place where we can pinpoint down the target resource. Now, as I said, service endpoint policies can only be used for Azure storage. That's why there's nothing to select here. The scope, that's what I mentioned before, in a subscription resource group. This time we're only going to limit the access to a single account. Inside my Azure Blue Dev subscription here, this resource group is RG demo, and the resource this time, that's the storage account that I prepared beforehand, is that one. We add it, review and create, and there we go. So this shouldn't take too much time. And okay, now it's finished. So as a next step, we're going to enable service endpoints on the subnet. As I said, it's a feature of virtual networking. So let's enable it on this vnet demo that I prepared. This virtual network contains two subnets. The default one, and here one subnet that holds my virtual machines that I've shown you in the diagram beforehand. So to enable it, we select the subnet, and there you find service endpoints. Now we can choose to what resource we would like to communicate via service endpoints. For my demo, we're going to choose storage account here, and also you see it lets me select the service endpoint policy. Now, I think we created that one here. That was the one. Let's select that. And there we go. And that's all what is needed to get this configured. And while this is configuring, this could take a minute or two. Let's see how we can lock down the access. Therefore, we are going to apply a network security group to the subnet as well. That says unsaved. What's the matter? Let's just wait. Ah, okay. Now it's gone. Now it's done. Okay. Okay. Remember, now we're on step 3. The first one was to create a service endpoint policy. Second one, enabling a service endpoint. Now we want to lock down the access. So I would now like to lock down the outbound communication of the virtual machine towards the internet. I therefore have this network security group that is linked to the specific subnet, as you can see here. We do this by adding an outbound security rule. You probably have seen this before. Source and this at this time is our IP address. I think it was 101.5, I guess. Source port range, we would like to block any communication towards the internet destination. In this case, we're going to select service tag as we want to filter all traffic towards the internet. Destination service tag internet is fine. Service custom destination port range, we want to limit all. So we just hit the star, protocol any, we want to deny it. Let's give it a name, a speaking name, deny all outbound internet. So, okay. And that's all there is to do. Now we're limiting the outbound communication. Okay, and last but not least, that's why we came here. We would like to lock down access to the storage account. And that's a configuration thing that can't be done via network security groups. We will have to do this on the configuration of the storage account resource itself. So let's switch over to our storage account. You will find settings, networking. And this is where we can select which networks are allowed to reach that point. We're gonna switch to selected networks, and you can see configure virtual networks, add an existing virtual networks that already got listed. And notice one important point here, it says endpoint status is enabled. If we would have forgotten to enable the service endpoint on the subnets, this would be denoted here. So you can't enable this filtering if no service endpoint is enabled. Okay, that's all that needs to be done. We're going to save this, and now we're finished. And just to emphasize my point, especially on the service endpoints, I would like to show you what the next subtype looks like. I therefore use Network Watcher, which is a great network debugging tool. We are interested in the next subtype in that case. That's why I'm selecting this. The virtual machine. That's this virtual machine. Maybe I'm sorry. Maybe this is too confusing. Let me go back and just show you the picture so you're not getting lost here. So as I said, enabled the service endpoint. We created the service endpoint policy, locked down the storage account, and now I would like to show you that the next subtype of virtual service endpoint is getting used. So back to that one. The destination IP address was, I'm sorry, what was it again? Give me a second. And I just closed it down. It's 20. Oh, no, it's not started. What happened? Stopped, really? No, okay. Okay, anyway, then let's pick the other VM. Doesn't matter. I hope you're still with me. Let's take that one. We don't waste time here. Next type. So now let's wait and see what it returns. Okay, this takes some time. Yeah, and there you see, next subtype now is virtual network service endpoint, which is the entry point to the Azure backbone. Okay. What's also interesting to see is maybe the routing table that applies to any of this virtual machines. You can look this up on the network interface. So let's select one of this network interfaces belonging to any of these VMs. Effective routes. And now it should list all the public IP address prefixes or ranges that are belonging to the storage account. And that's what we see here on this line. See, and it really adds all of them. Okay, 503 and even more. So this is a huge range of public IP address ranges now pointing to this virtual network service endpoint next hop type. Okay, are there any questions so far? Okay. Okay, as we have already learned, the key benefits of using service endpoints is that the traffic always remains on the Azure backbone. That comes with high bandwidth usage and, of course, low latency. Of course, there's enhanced security attached to it, and also there's optimal routing, right? Because packets don't have to travel. I mean, imagine that if you have a configuration setup where all your packets are traveling through your on-premises network, where maybe the reason could be that they would like to have total control over all the outbound network traffic. With service endpoints, it's ensured that even with such a configuration, packets would still travel the optimal route and won't go into your network, onto your on-premises network and travel back to Azure. This is because the service endpoint routes override any BGP or UDR routes. Yeah, and it allows tight lockdown. As we have seen, without service endpoints, you're not able to tightly lock down or control on the VNet. And last but not least, service endpoints come for free. There's no additional charge as it is part of the virtual network. Secondly, sorry for that. You can even secure your services to multiple subnets within a VNet or even across virtual networks. The virtual network and the service resources, they can belong to different subscriptions and even tenants. However, this is a small caveat. VNet service and the VNet and the service resource, they can't be in different regions. And of course, there's a small exceptions which applies for paired regions. So if your VNet is in West Europe and your service resource, for example, your storage account is in North Europe, it will work. But it won't work if you host your storage account in East US, for example. Okay. The limitations, there's always a downside to everything. This feature is only available to VNets that are deployed with IRM. There are no classical, it doesn't apply to VNets that are deployed via the classic model. It only can be used for traffic that's originating from your VNet. And not every Azure resource is supported. So there's a limited list of resources that you can talk to via service endpoints. But I would say that the most important core building blocks are available. And as I mentioned before, service endpoint policies can only be used for storage account. And of course, they can't be shared across subscriptions. But this limitation, to be fair, applies to other resources as well. So, okay, and this concludes service endpoints. And next up, let's have a look at what private endpoints are and how they compare to service endpoints. Again, I will give you an overview of private endpoints and the private link service, as private endpoint is part of the private link service. That might be confusing. And there's an important component, which is called private endpoint DNS integration. We will look at that. I will demonstrate you the approval workflow and conclude with the key benefits and the limitations. So again, private endpoints or service endpoints allows to eliminate exposure and data exfiltration. It allows you to limit your communication onto the Azure backbone. This private link service is a standalone resource as opposed to a service endpoint that is part of VNet. Private link service consists of three main components, which is the private endpoint, that is the consumer-facing service, if you like. There's a private endpoint DNS integration part, and we have the private link service, which is the provider side, the offering side. Yeah, it enables access to Azure hosted platform as a service services, but you can also access partner service. For example, let's imagine you have a joint venture with a partner company and you would like to access their storage account privately. Then private endpoint is your go-to solution. But you are also able to offer your own services over a private endpoint, which is depicted here in this little box here on the top, where the provider side is hidden behind a standard load balancer. But this part, which is the offering part, is beyond the scope of this presentation. We are going to focus on the client-facing side, and that's why the title of this presentation is slightly changed as opposed to the invitation, as it's more accurate to compare private endpoints to service endpoints as to compare the private link service to service endpoints. Okay, what's next? What is a private endpoint? A private endpoint is a special type of network interface, and it's a read-only network interface that plugs into a virtual network, as depicted here in a diagram, and it consumes a private IP address of your subnet. And this will ensure that traffic remains on the Azure backbone. And right on this diagram, you will realize that there is a fundamental difference than service endpoints, because there's no routing involved, right? Traffic remains inside this subnet. Of course, on the resource side, on the implementation side, on the Microsoft side, travel will have to leave somehow the subnet. But from a customer or client perspective, data travels from your client, stays in your vnet. Okay, so I mean, this diagram basically depicts a hub-and-spoke architecture, where we're having the hub in the middle and the spoke vnets on the left. Both are part of the service consumer side, as seen on the top, service provider on the right side. And this diagram, I think this diagram basically shows it all. It allows to lock down access from the internet to your service. And it also, as opposed to service endpoints, you can use this private endpoint from your on-premises devices if you have a link via ExpressRoute or a site-to-site VPN. Also, private endpoints can be used from peered network, as shown here in the diagram. Okay, now we don't want to talk to this private endpoints via IP address. We would like to talk to DNS names, and that's where this private endpoint DNS integration comes into play. Every time where you're going to create a private endpoint, Azure is going to create a CNAME record on the public DNS for you. Now, the canonical name or CNAME record is an alias that kind of maps one domain to another. A CNAME never points to an IP address; it always points to a DNS name. Then at the same time, when you create a private endpoint, also a private DNS zone is created and linked to a VNet that overrides the public DNS. And the reason why it does so is so that a caller won't have to change any existing URLs. So that means that if, as shown in this picture here, if a client calls this database here, it is able to use the full qualified domain name, the public domain name, which will result in a private IP address, will resolve to a private IP address, and when queried from the outside, it will resolve to a public IP address. But both are querying the same DNS name. So this flow here shows how the DNS resolution works. We got a client here and a private endpoint that's part of the subnet, that is part of a bigger VNet. We got the source that is linked to this private endpoint here. And now a DNS query happens to the Azure provided DNS that is integrated into Azure. And it will forward this to this DNS server here, and will receive a CNAME reply. So please note that the query is for the public DNS name, and it will respond with a canonical name, with an alias that points to private link database windows.net. So it's an additional zone. Next, the Azure provided DNS will query again this private DNS zone that got created beforehand when we created the private endpoint, and will respond with an A record this time that points to the private IP address, right? Because we are querying this from the inside, so this is the intended behavior. Okay, and afterwards, of course, the connection happens to the target resource. Now, let's see what the DNS query from the internet looks like. This kind of the tool I'm using here is a DNS debug utility dig for Linux, and what I do is I query for this public DNS name, and it returns with a CNAME record, an alias that again points to another alias, which again is an A record pointing to the public IP address, right? And this situation implies that from a security perspective, this implies that even if you query for the private link domain name, you will always end up with the public IP address. The private IP address is not going to be revealed from the internet, okay? I will show it later in a demo. This might be complex by just looking at the screenshot. Why again did I add this slide? Right, I wanted to emphasize my point that on the right side we see a query for a public storage account where private endpoint is enabled, and you see here it's slightened. It returns with a private link, and on the top there's one query for a storage account that has no private endpoint enabled, so no additional CNAME record here. And on this screenshot on the top left, I would like to show that no private IP addresses are revealed. We are querying the public one. We are getting the public IP address in return. And again, if we query for the private link, we also get the public IP address, which is the intended behavior. Okay. Now, what does it look like from a VNet perspective? This screenshot shows a DNS lookup from a virtual machine that is part of the VNet. Again, we do a lookup on the public DNS name, and it returns with a CNAME, as I've shown before, which again points to the A record. So Azure Blue demo 2blob.core-windows.net is an alias for the private link one, and private link finally points to the private IP address. So this private DNS zone overrides our DNS resolution. And as I have said before, it implies that a caller doesn't have to change any existing URLs to the target resource, which is pretty handy. If you think about legacy source code, it might have hard-coded strings and so on. Okay. And the last picture that I'd like to show in the context of the DNS integration is this Happenspoke architecture. In the middle, we got the hub and the spoke VNets, the left and the right, and all of them are sharing one private DNS zone, which is vital. Otherwise, the DNS resolution, of course, won't work. And this is possible because a private DNS zone is a global resource, right? It is not locally bound to a data center. Okay. Last but not least, one additional feature of private links is the approval workflow. On the left side, we got a service consumer side, and the right side we got a provider. So it assumes that there's already a provider, and a consumer would like to connect privately to this service. So what this consumer does, he creates an endpoint and enters the resource ID of that private Azure public endpoint, and a request is going to be sent out to the provider of that resource, and the provider can act accordingly on that, can approve it or reject it with an additional comment. This decision will be forwarded to the consumer, and he can act accordingly upon it. There are basically two connection approval methods. One is an automatic approval, which applies whenever the requester has enough permission. Then there's no need for manual approval, right? So this will be done for you on the background. And there's the manual approval, and this applies when the offering resource is outside of your tenant or belongs to a third party that you'd like to connect to. Okay, last but not least, again, enough of the theory. Let's see some demo. What we now are going to do is we're going to create a private endpoint. Again, pointing to our storage account, demonstrate how the DNS integration works, and I will also show you the approval workflow. Okay. Let me just escape out of this presentation. So far, any questions there, or is it clear? Okay. Okay, private endpoints. Back to our portal. This is part of the private link service. That's why you're going to find it here, private link. You will find private endpoints. Simple as an add. Okay, which subscription do we want to create this private endpoint? Select a resource group, give it a name. Again, that's good. I'll try to follow the Microsoft's naming convention here. Azure Blue Demo. Okay, let's deploy to West Europe. Connection method. Now, you would like to connect to a service, a storage account that is part of our subscription or directory, so nothing to change there. The resource type, the storage account. These are my 3 storage accounts that are part of this subscription. We're going to choose the first one, and this is important. It lets us select a target subresource. Let's take the blob. Now it asks me where do I want to deploy the virtual network interface to. I want it to deploy it to the subnet, and I want automatic integration with the private DNS zone. I'll leave it as it is. Tags, no, that's fine. Review and create. So let's create this on the background. In the meantime, collect my virtual machine. So it has already created the private endpoint. Now it's deploying the DNS zone. Come on. In the meantime, yeah, I got a little ahead of myself here. What you're looking at right now here is the terminal of this VM jump host that is part of the vnet, where we are now currently adding this private endpoint to. And we choose the storage account, Azure Blue Demo, where the blob part resolves to this full qualified domain name. Now, as you can see, it still resolves to the public IP address. I mean, the deployment is still in progress. Now it's getting linked to the subnet. So, come on. There it comes. Okay. Plus. Just a second. Have I chosen the wrong one? Is it blue table? No, it should be the right one. Okay, just to show you. Okay, the private endpoint got created. And if we open the resource, you will see that it's connected to this private link resource, so a storage account, and it's connected to this subnet here. And it has created this virtual network interface for us, which is a read-only network interface. If we click on it, we see that it has a private IP address of 10.0.1.5. And now I'm just curious why it maybe. Now you see. Okay, there we are. Now it resolved this public DNS name to a private IP address. Okay. Let's do the same from the outside. This is my local machine connected to the internet, and let's just see. My public IP address currently is that one. So if we do a lookup on the public DNS name, it will return a public one. So okay, and now we are able to lock down the storage account, as we have seen before. No big thing here. Just go to the network, and yeah, we already did it. Just lock it down. Okay, good. That was one part. Now the last part that I wanted to show you is the approval workflow. I therefore have prepared. I have two subscriptions, and therefore I have a session in it. Just a second. And sorry for that. Yes, please. There we are. Okay, two subscriptions, both in the same tenant. And there's my storage account that is part of this prod subscription, and the other one that we've seen on the back here is are belonging to the dev subscription. So what we need to enable this is the resource ID that can be found here in the properties of the storage account. I guess, well, yeah, storage account resource ID. I think I added it here just to make sure I'm clicking the right one. Oh, sorry for that. I think I added it here. There it is. So this approval workflow, I mean, a provider would now send this resource ID to a possible client, someone that would like to connect. And to connect to that resource, we go to the private endpoint. Again, we go to add, nothing special here. Select a resource group. Now we say Azure Blue IO, which is our prod one. Let's make it more clear, more obvious. No. So and now here's the difference. Connection method, connect to an Azure resource by resource ID or alias. One target sub resource can't be selected. We want to limit the access to a blob. You can give some request message, access, whatever. Again, we want to block this into our subnet, and this is important. You cannot automatically integrate with private zones. So if you follow this workflow approach, you would have to take care of that yourself. I'm not going to show this here. So let's create it. Deployment in progress. Let's wait for it just a second. Then see. Okay, you can see in the background that the resource got deployed. On the storage account, if you go to networking inside the settings, you see the private endpoint connections, and you can see, okay, there is one request hitting our storage account with this description here. Let's give me access. Okay, now I can approve or reject it, and everything is good. There you go. Okay, I think you got the hang. Okay, so this is, and I got approved. And if we go back to the requester side, you can see here the connection status is in state approved, and the response messages. There you go. Okay, and this finalizes my demo for private endpoint. I think I made the point clear that it allows to eliminate exposure to the internet, and it also can be used as opposed to service endpoints to connect to resources across regions, and this is different from service endpoints. It offers approval workflow, which service endpoint doesn't, and it offers a lot more resources than service endpoints do. But also there's the downside. Private endpoints can't be associated with network security groups as traffic stays inside a subnet. The user-defined routes don't apply because we're not dealing with the routing here. And the private endpoint, meaning the virtual network interface, must be in the same region as the virtual network. Otherwise, they can't talk to each other. And as an alternative, you could create a hub-and-spoke architecture and use global peering for that to work around that limitation. Okay, that finalizes this section, and let's now compare both to each other. There's a long list. On the left side, we see service endpoints, and on the right side, the private links. I said before, service endpoints, they are free of charge, whereas private links, you get charged based on traffic and usage time, though it's not much. Service endpoints do not come with any SLA, as VNets also don't come with any service level agreements. Whereas the private link service comes with a 4.9 SLA. However, one could argue that a service endpoint has a higher availability than private links have, because for a VNet to go down, the entire region needs to go down. Service endpoints feature a virtual network, private links a standalone feature. With service endpoints, the provider needs to be in the same region as the VNet. And for the private link, it's independent, right? So you can really communicate across regions. And yeah, then private links, they must be deployed to the same region. The virtual network needs to be in the same region as the virtual network. Service endpoint needs to be enabled on the subnets where you would like to consume it. I mean, if you have more than one subnets, which you for sure have, then just enable it there as well, and you're good to go. So no big deal there. But also, service endpoints, you don't consume any private IP address, whereas the private link service or the private endpoint consumes a private one. And you can't use service endpoints for traffic coming from on-premises or peered networks, whereas you can with private endpoints, as I shown in the architecture before. Then with service endpoints, the service discovery entirely relies on routing and on this additional hop type, whereas the service discovery on private endpoint relies entirely on DNS. With private endpoints, there's some special thing that might, push you in a different direction when it comes to choosing between two services, because private endpoints allows you to inspect the traffic via an Azure firewall. You might have some regulations that tells that you need to do some sniffing on the network traffic, and this is possible with private endpoints, and it's not with service endpoints. Service endpoints supports only 14 resource types, whereas the endpoint supports up to 27 services. When you enable service endpoints on the virtual network, a short interruption on a subnet might occur, and this might be acceptable. It might not. It depends on your use case. That's something that doesn't happen when you use private endpoints, as you just plug in an additional network card, right? And then also when it comes down to filtering, service endpoints has a kind of a CORS, only provides a CORS option for filtering based on the service endpoint policy we have seen. Whereas with private links, you have a lot more control on the endpoint that you want to talk to, that you want to allow the communication to. This is just a list. I don't expect you to read it all. I just wanted to show you the differences, all the offered services, service endpoints on the left column, and private link resources on the right, just to make the point that there are some services offered from both of them. Some are only offered via private endpoint. One thing to note here is that, for example, if you want to privately communicate to an Azure Data Link Storage Generation 1, you would have to use service endpoints. There's no such offer with private endpoint, right? Okay. Now, final slide, which one to pick? Of course, if you're tight on budget and money plays a big role, service endpoints is the right direction to head to. And but this is only usable if you are within a single region only. And as I mentioned before, if you must privately connect to a data lake storage generation 1, then you have to stick with service endpoints. And if filtering via service endpoint policies is sufficient for you, then also service endpoints is fine. However, if you require more sophisticated scenarios, and as mentioned before, you have the requirement to inspect or sniff traffic, then private endpoints is the go-to solution. And especially if you have a global setup where you need to communicate across regions, you have to use private endpoints. And yeah, and of course, I mean, I'm just stating the obvious here, but if you must connect privately to a service that is not offered by service endpoints, okay, that's just the obvious that I'm stating here. But I think these are some kind of the basic questions that form your decision path when choosing, when having to make a selection on one of them. Okay, and this brings me to an end. Thanks a bunch for your attention, and in case there are any questions, please raise your hand or just let me know and I will try to answer them.